What is slope? How to find it. This video is for all you having questions about the slope, and I just really want to just make it as simple as I can, which may not be as simple as you would like, but I'll do my best. So, when we're talking about slope, we are referring to lines that we graph, but let's just take a look at slope without a Cartesian plane or without anything. So let's say you are a person, you're a human person walking on a path, and you're just walking, you're minding your own business, doop-a-doop-a-doop-a-doop. That surface you're walking on, you're just walking in a straight, flat line. You're not going up and down, you're just walking. That is considered zero slope or no slope, because slope is just a measure of how much up or down you're going with every step you take. I'll say that again. Slope is a measure of how much up or down you're going with every step you take. So in the instance where you're just walking, you're not on a flat surface, you're not going up or down, you're just going straight. So this is a zero slope. Zero slope. And remember, and just for the sake of algebra stuff, we usually represent slope with an elm. So elm equals 0 is what we would say. So next scenario, you're walking, you're in the mountains of a state. You pick the state, and you're walking along, and then you start to go up the mountain. So as you walk, you take a step, you go a little higher, you take a step, you go a little higher, take a step, go a little higher. With every step you take, you are going more and more up. So this is considered a positive slope, because with every step you take, you are going more and more up. So slope equals, I'll just do a plus for positive, but that could be different. It could be positive. It doesn't really matter what the number is right now. Just know we would do a positive 2 or a positive 4 or a positive 106, depending on what the slope is. But for right now, just know that for every step you take, you're moving positive. This is a positive slope. Now, you go up the mountain, and now you're at the top, and now you start going again. And now, with every step you take, you're starting to go down the mountain. Doop, 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 doop. You start going down. So this is considered a negative slope, because with every step you take, you are going down. Negative slope. So we've got a zero slope, we've got a negative slope, we got a positive slope. Okay, so now you're walking. Uh-oh. You come up to something straight up and down. It's a wall. Can you walk? Can you walk up a wall? Can you walk up a wall like this? No, I don't think so. So it's not a zero slope, and it's not a negative slope because you're not going down with every step, and it's not a positive because you're not going up with every step. There's no slope at all. It's a wall. Walls aren't slopes. Walls aren't slopes. We say the slope is undefined. Undefined. And that's the best we can say about walls. We can't measure it. It's not a slope. So these are the 4 instances of things we might run into when we graph. Now the question is, how do we measure slope? So in this lesson, in this right here, we learned how we can tell whether a slope is 0, positive, negative, or undefined. This is the type of slope. Now let's actually figure out how we can measure it. There are 3 main ways, main scenarios where we would need to figure out the slope. Scenario number 1. We have a line graphed on a graph. Let's say it's this right here. So scenario number 1, we might need to figure out the slope of a line on a graph. Scenario number 2, we are given 2 points, and we need to find the slope of the line between these 2 points. And to just make that more clear, these 2 points, if we graph them, they make a line in between them. So we need to know the slope of the line these 2 points form, but right now they just give us the 2 coordinates. So that's what we need to do to figure out the slope. Scenario number 3, we are given the equation of a line. Y equals 4x minus 2 or something. I don't care, just that. So, all right, so let's start with scenario number 1, where we're given the line on a graph. So This isn't the best example because there's a little bit of a mess, but just pretend this is a line right here, okay? So, which it is, but use your imagination a little bit. All right, so we got 2 lines on the graph. So we say, hey, what's the slope of this line? So we want to find where the line intersects some hash marks. One place that happens is right here. See how it intersects 2 hash marks? Another place is right here. Another place is right here. Another place is right here. There's all sorts of places where it intersects a hash mark. So we go to one hash mark, and we go, and we go to the other. Erase that one. We go to one and we go to the other, and we say, all right, if I'm starting here and I'm going here, how can I get there by following the hash, following our boxes? So we go up and then we go over. So we go up 1, 2. See how we're counting our moves? Just we go up 1, 2, and we go over 1, 2, 3, 4, 5. So we go up 2, we go over 5. 1, 2, 3, 4, 5. So we say our slope is 2 over 5. That's our slope. We go up 2 over 5, up and over. So we can do that again. We can start here and say, how do we get from this point to this point? We go up 1, 2, we go over 1, 2, 3, 4, 5. So it's going to be the same thing everywhere on our equation, or on our line. It's going to be the same slope everywhere. So we call this up. We actually call this rise over run. So rise over run. So then we have a slope of 2 over 5 in this case. Let's take this scenario down here. There's an intersection. There's an intersection. And there's an intersection right there. You don't believe me, but just trust me. So now we go up and over. Oh, if we're trying to get from here to here, we can't go up because it's down. So we consider that going down to 1, 2. And we go 1, 2, 3, 4, 5. Perfect. Now, because we went down, that's not a positive 2 anymore. That's a negative 2. So we go down 2, 1, 2, 1, 2, 3, 4, 5. So it has a slope of negative 2 over 5. And if we were to do it again, 1, 2, 1, 2, 3, 4, 5. Slope of negative 2 over 5. That's our slope. Now, we don't have to do 2 of the same points in a row. Let's go straight from this point to this point. So we go up 1, 2, 3, 4, and we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we went up 4 and over 10. But what's special about 4 over 10? It reduces to 2 over 5. So no matter how we count it, it will be the exact same slope. If you didn't get the same slope, something's a problem. Okay, scenario number 2. Scenario 2 says, what if they just give us 2 points? So we have a line, and it's got 2 points on it. Let's find the slope. So in this scenario, we need to use an equation. y2 minus y1 minus x2 minus x1 over x2 minus x1. Now, it looks a little tricky. These little numbers are subscripts. This just tells us, hey, we're working with 2 different y's here. Which one's which? It just works as a label. So this is our second y value. This is our first y value. This is our second x value. This is our first x value. So if we look over here, remember that coordinates are made of an x coordinate and a y coordinate. So we got our xy pair right here. So all we got to do is we got to take our y and we got to plug it in right there. If we take our x and we substitute it right there, and then when we get to our second equation, or our second coordinate right here, we take 1, 8, plug it in there. We take our 4 and plug it in there. So this is what that's going to look like. So y2, pick out a y. We got 3 minus the other y, which is 8, over x. We pick 2 minus the other x, which is 4. Now, it's very important. See how these 2's line up? This means they came from the same coordinate. So see how 3 and 2 came from the same coordinate? And then 1, 1 came from the same coordinate. So your coordinates should line up with each other, up and down like that. But the main idea is we're subtracting the y's, we're subtracting the x's. So 3 minus 8 is negative 5. 2 minus 4 is negative 2. Negatives cancel, we're left with 5 over 2. That's the slope of whichever line passes through these 2 points. So now, for a visual demonstration, let's graph those 2 points. We've got the point 1, 2, 1, 2, 3 right here, and we've got the point 4, 7 right here. If we were to graph it, it would look something like that, but let's use our previous method. If we count up and over, 1, 2, 3, 4. Wait, did I do something wrong? Oh, I graphed it 4, 7. That's what's wrong. Please hold. There we go. So using our previous method, we count up and over 1, 2, 3, 4, 5. 1, 2. So 5 over 2. Just like we got when we subtracted. So this coordinate method is just, it's the same thing as we did in the first example, but now we don't have to graph it. We can go straight from the coordinates to our slope. Okay, now, final example. Example 3. What if they give us the equation of a line? Y equals 4x minus 2. How do we figure out the slope? Now remember, equations of a line, this just gives us instructions for how to graph a line. Now, I'll tell you right away. Our slope is found right here. It's the coefficient on the x. So we know that our slope of this line is going to be 4. 4 equals the slope. Now, very important. This only works when y is by itself on one side of the equal sign, positive y. Positive y is by itself. Now we can look at the coefficient. We know that our slope is 4. So let's take a look. Let's say we were to graph this. It's y equals 4x minus 2. Negative 2 is our intercept, so we know we've got a point right here at negative 2. And our slope of 4 tells us go up 4 over 1. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. And we graph it just like that. Now, if you wanted, you could do our other methods to count up and over, but if you just see an equation, you know what the slope is immediately when the y is by itself. So that's about it for a summary of slopes. Hope it helped. Bye.